Thank you very much, and welcome to our first ever Emberfest panel. I really don't know why you haven't done this before. I think the panel format is a great form to discuss some ideas, and I'm personally very intrigued to talk about scaling in Ember, as I think it's a fascinating topic. We'll have four panel members. So remotely, Pat O'Callaghan from Intercom, Chris Cryho of LinkedIn, and then Jamie White of HashiCorp. And we have Jan Buschtöns here with us on site. So just very quickly to set the stage, so to speak, we're talking about scaling. I think there are several concepts or several meanings behind this word. Scaling can mean scaling a team as they grow or as the company itself grows. Scaling can mean that the code base is growing. There are more apps or a code base is getting bigger, and there are certainly challenges with that too. And there is also I think, which is the most strictly technical meaning of the word, which is scaling when you have more data, more components rendered on screen, so to speak. So let's start with Pat from Intercom, and let's hear about what scaling challenges Intercom faced along all those years.
Hey, Emberfest, nice to meet everyone. So scaling has been interesting at Intercom. Just to give you a bit of context, if anyone knows the Intercom product, we have a messenger which we install on people's websites, like a live chat. That's built with React. But the dashboard app, which our customers spend, like thousands of our customers spend multiple hours a day doing like things like reports, dealing with customer queries. That's our Ember app. And that app has existed now for nearly 8 years at this stage, and been using Ember. So it was previously a Rails app. We've migrated to Ember about 8 years ago, and thankfully we're still on Ember. I found that Ember has just helped us scale through that, especially in the early years, because the early years there wasn't as many strongly opinionated frameworks. And especially in the early years, we wanted to move fast. We wanted to figure out our product vision, what do we need to build. And all these strong opinions helped us move fast. Up to the point where today as I said, we have a monolith. We haven't broken apart the app at this point, but I did some number crunching yesterday. We have close to 4,000 components. We've something like 600 routes in our router.js file. And we have multiple teams across multiple locations, all kind of working independently on the same code base. It's been an interesting journey from the early days right up till now, where we're still scaling, we're still growing, but kind of Ember has definitely been every step of that way, and has been fundamental in our journey all that time.
Chris, could you go next?
Hello, Emberfest. Good to see all of you. It's 6:45 a.m. here, so it's nice and early. LinkedIn has been using Ember for the main app you think of as LinkedIn since we started building it in early 2015. So we're coming up on 7 years now. How time flies. Kind of challenges we face really hit all of the things that, were called out there as kinds of scaling challenges. So we have, at this point, in any given quarter, between 150 and 200 developers committing to the repository for the big app. We have a couple million lines of code. We have many, many hundreds of millions of users. I think that's the right number. I never keep track of the scale of our user base because it's big enough that my head doesn't track it anymore. And we have to ship engines and break everything apart. We have to make sure that we are delivering a good experience for our members that way, because if we shipped all couple million lines of code down at once, it would take 6 years to load, and, can't do that. And of course, we also use Ember pretty extensively across the company for other things. LinkedIn Learning is an Ember app. Our recruiter app is another Ember app, and so on. So we have millions and millions of lines of code. I think we'll dig into more of the ups and downs as we go through the panel, but I'll say the biggest upsides for us have definitely been that you can pop from our recruiter app over to our big app and then over to learning and wherever else. And things are going to feel pretty similar. There's going to be some consistency in how things work and where to look for things, et cetera. And we've been able to move consistently forward over that long period of time. So that when we started, it was early 2.x days, and here we're cleaning up deprecations for 4.0 and just mostly steadily marching on. So that's been very helpful as we've grown. The number of people who've touched this code base over time, I think, is the one I work on most, is over 500. So being able to just have a well laid out pattern, it's been very good. We've had some challenges, but like I said, a lot of good along the way as well. So I'll leave that for the summary and come back for more later.
Thank you. Jamie.
Hi, Emberfest. I wish I could be there in person, but sadly not this year. So I work for HashiCorp these days and previously worked for Heroku for about 3 years. And at Heroku, the thing you know is the Heroku dashboard is a big Ember app that's been around for a while, has dozens of people working on it, and has gone through different versions of Ember. I remember during my time there, it shifted from a kind of home-rolled precursor to Ember Data to going all in on Ember Data, and that was an interesting experience. And now here at HashiCorp, the things are sort of equal in the sense of scale, but the number of Ember apps is a little different because I'm not sure, well, some of you I'm sure know the HashiCorp suite quite well, but many of HashiCorp's open source tools ship as a single binary that you download and run either in your infrastructure or on your own machine if you just want to try it out. And many of those binaries have an Ember app embedded within them. So there'll be a server that serves some HTML, and that's the Ember app. So Vault, Console, Waypoint, Boundary, I'm sure I'm forgetting others. They all have these Ember apps embedded inside them, shipped in a Go binary. It's a very interesting process. And then HashiCorp also has the HashiCorp Cloud Platform, which is a kind of, I guess, the more traditionally deployed kind of Ember app. Oh, and there's also Terraform Cloud. There's Ember apps all over the place. And so the interesting challenge there is how do these different teams, which are siloed in some ways, collaborative in other ways, how do we share best practices with each other? How do we literally share code with each other? And yeah, I think that's probably something we'll get into over the course of this panel too. But that gives you a sense of the kind of stuff that I've experienced with.
Thank you very much, Jamie. And then over to Jan.
Yeah, my name is Jan. I'm working at Clark. We are basically a wallet for insurances and also an insurance broker. And we serve about, I think, 350,000 customers by now, have an engineering team of around 80 people, are still trying to grow even further. And our M application is about 4 years old by now, and we've been steadily upgrading into the latest version. One of my colleagues, Isaac, actually did the latest upgrade from 3.24 to 3.28 now. And the main issue that we are experiencing currently is that the build times are getting really slow because we were trying to split up the application into smaller parts and smaller packages so that we can have individual teams working independently on separate parts of the application, have one team focusing on certain parts of the UI, and then have various engines for the various main parts of the application. And if you then bundle all that together in one build process, that tends to get really slow. So our hopes there are that in the future, with the advent of Embroider, new build system by Ed Faulkner, we can hopefully start pre-building many of these things and avoid doing the build in one go. But then again, many advantages of the Ember build system, Ember ecosystem are also that you have this great, really helpful community. When we get new engineers in our team that never worked before with Ember, we can point them to a lot of great online learning resources, great books, of course, also, and also the ever helpful Ember Discord. And that has definitely been a major plus in my book for Ember.js. And I think that we have been steadily sailing along, and it's super simple to get involved in all this and steer the whole Ember project into a direction that it can serve your needs and that everyone can benefit from it. So that's really great.
Hello. Yeah, so scaling an application probably also means hiring new people, right? And stuff that I hear from clients in the past few years is that it's just hard to find people that know Ember, right? And some of the people I talked to even switched away from Ember because of that, right? They just told us, hey, it's impossible to find Ember people. Is that anything that concerns you in the bigger companies as well, or is it just no issue for you at all?
It definitely has been an issue for a certain amount of time. There were some people in our company that said, oh, well, maybe we should switch to React because everybody's doing React these days. But these concerns basically were silenced over time. It is definitely not super easy to find qualified Ember engineers right away. But we found that you don't even need someone that has Ember experience. As long as you have experience with any framework, be it React, be it Angular, Vue, Ember or the fundamentals of Ember are actually quite easy to pick up in our experience.
Yeah, I'd echo that. Generally, at Intercom, we don't specifically hire like Ember engineers. We'll generally hire like generalists or people who just know how to program or have used. Even like people that haven't used even front-end technologies. It's the same with even with our back-end stack. Like we'll hire people who on their first day have never seen Ember or similarly have never touched a line of Ruby code. So for us, it's generally not an issue. So you'll in our job postings, you'll never like specifically say we're looking for Ember engineers. Generally, we find if you're a good engineer, you can kind of pick up anything.
I'd say similar. We have onboarding that helps people learn the basics of Ember when they first come in because you may not have it. But if we were using Svelte or Elm or whatever else, we would do exactly the same thing. Fundamentally, I understand where companies are coming from when they have that mentality. They want people to be able to hit the ground running immediately and have no ramp up time. But the reality is unless you're using something very obscure, the largest amount of ramp up time is nearly always going to be on the details of your product and your code base and the things you have to learn about how does your API differ from the last API you were working on. We at LinkedIn, we use M3, which is a variant on the Ember data approach because shipping all the Ember data models to production cost way too much in payload for us at our scale. So 3 or 4 years ago, we built M3, which basically says you ship one schema and everything happens dynamically. And the M3 layer can interpret things as it comes across. Well, that's a new thing for nearly everybody. Almost no one has worked in a thing that has a megamorphic model schema as the way they drive their data layer. And that's fine. We teach people, we help them get up to speed. We're always dealing with the fact that we don't have enough docs or enough training materials. But that doesn't have anything to do with learning Ember. It doesn't have anything to do with learning those kinds of framework-specific things. They're our own specific constraints because of our own needs. And that's going to be true anywhere you go. When I onboarded at my previous company, Olo, I had done web development and then I learned Ember at Olo, and learning Ember was not the hard part. Learning how restaurant menus worked, that was the hard part. Spoilers, restaurant menus are really complicated. You don't think they are, but they are. That's always the case. And so as others have said, I'm always much more interested in finding engineers who can learn and grow than I am in Ember specific stuff. The only time we really care at all is if we're hiring somebody for our core infra teams who, like me or folks like Rob Jackson and Steph Penner and others, tend to work directly on Ember things. Like, yeah, you probably need some Ember expertise there. Beyond that, you can learn it as you go. And the hard parts are always the product bits anyway.
Yeah, I'll echo what everyone else has said, which is in my experience, anyone who's done some React or some Vue or whatever else will have no problem doing almost all aspects of Ember development. In fact, I think it seems to me that these days there are arguably fewer concepts in Ember than there are in the typical React application. Sorry, shots fired. I don't mean to start a flame war. And when it comes to the sort of infrastructure engineer that Chris was just talking about, the kind of people who can debug a very slow build or, do something complex down at the Ember CLI layer. I think I would argue there that really that specialist knowledge, no matter what stack you're using, if you had started life on Create React app, you're probably going to need a Webpack wizard to unpick really knotty problems there. Like that stuff doesn't get any easier with a bigger pool of potential candidates. In fact, the bigger the pool of candidates is, the less certainty you have that those people, kind of have that specific experience that you're after. That said, it is a perception issue for the people running a business to know that they are going to have to work a bit harder to hire the kind of people they're looking for. There's a smaller pool of candidates who have, if you are looking for that specific experience. And that's, I think that's a real challenge for Ember, but I think that is to be weighed with Ember's kind of sober approach. Ember is sort of, at this stage, quite a conservative choice of tool. And I think that really suits a lot of businesses, especially, bigger businesses. So it's a trade-off, as everything is.
To riff a little on Jamie's last point there about that in-house expertise, I've dropped a link from an engineer named Dan Liu, who currently works at Twitter. He's worked at Google and Microsoft as well, just on the value of in-house expertise. And that if you're a sufficiently large point, you're going to see the value of in-house expertise on many of your core technologies. But at that point, you're always looking for those people, whether that's a kernel expert. His example here is Twitter has people who know the Linux kernel really well. And you might think, what? And he drops this post to kind of walk through why that's valuable. And the same thing tends to be true once you're sufficiently large for any of your fundamental technologies. And that would go for React. That would go for Vue. That would go for Svelte. It would go for Java. It would go for C#. It would go for Rails all the way up. That's why GitHub employs Rails devs and so on. So strong agree there. And this thing I've dropped in the chat, which obviously is not currently directly available to folks in the room, but hopefully we can make it available. Very good post, which I highly commend to you as very informative, very good argument.
Then I think we can go on, and you already touched on a few scaling challenges along the way. I think in a second round can kind of elaborate on those. Like I think some companies take the approach of having a big monolith, others, take it apart and have several engines. So yeah, I would like to ask you to maybe tell us more about the details of those challenges. Yeah,
so I think it's already brought up, but I think one of the main challenges we're facing is like the feedback loop, so build times, periodic surveys with our engineers, and like a lot of the time it's like our fast reload times. We've kind of made things better by like introducing things like hot reload, but still on the testing side, things can be a bit slow. Also with the performance, the payload size is also they're like the two main, I think, issues we have. We did look at engines a while back. We did do some prototypes to see, but there was like a massive kind of investment to do that. And kind of Embroider was on the horizon. So we kind of decided to take a wait and see approach. And kind of at the minute, we're kind of just kind of sticking with it. And hopefully we'll see some improvements. I'm not going to say like Embroider's going to solve everything, but I think we're hoping that, we can make that decision later.
Yeah, I should have mentioned we are also interested to see how Ember specifically helped to address those problems, or maybe when Ember did not help, you wished Ember did more to address those challenges. Yeah, with that, I pass the word to Chris.
I would start by echoing what Pat just said. We do make heavy use of engines, but I would actually say that engines are, with zero disrespect intended to the folks who built them at the point when they built them, because part of the problem is they haven't seen nearly enough love in the interval since then. Engines are a very costly abstraction. They're high overhead in the sense of you just have to load a lot up into your head to be able to use them well and effectively. And they're a sharp tool in that they are easy to get things wrong. We don't have great lazy loading primitives. Engines are basically it. And engines are easy to accidentally bundle things you didn't mean to, easy to end up doing things in terms of your order that you're including things, easy to end up accidentally assuming something is present because your test suite says it's present because we currently load everything in the test suite. And then you get to prod and the order in which you loaded your engine suddenly matters. So the order in which somebody navigates through your app means it might work or it might not, things like that. We've been working on building tooling in-house to catch that for a long time. We have, internal scripts that go through and check your package JSON files and say, do you depend on the things you should? And we're moving toward a world, and Embroider requires this. So this will be very helpful, where you have to explicitly say, these are the things I depend on, whether that's within my big repository or not. But that's been a huge challenge and pain point for us. That tool in particular is, I think everybody who worked on it and built it would say the same. Like it's well known that it was a 0.5 release for a long time, a 0.4 release for a long time. And I think the version we were shipping at LinkedIn is on 0.6. And yeah, 0 dot whatevers is not always the clearest signal. But here I think it accurately reflects the state of how baked that is. I would add to that we don't have tree shaking, and it's 2021. And we've been talking about tree shaking in the Ember community since before I was writing Ember. It's been like we were talking about tree shaking stuff in the late Ember 1 days, and we haven't gotten there yet. And that's a cost in terms of what we end up shipping to end users. What, as LinkedIn, we make our members pay in download costs that we really want to see go away. And I think we are at last getting there with Embroider. I mean, we're integrating Embroider into our CI pipelines to make sure that we keep building against it and can use it and all of that. But it is a cost. It is a challenge for scaling. I also think that there are pedagogical, that is teaching challenges with certain legacy parts of Ember. The Octane programming model is fantastic. I love it. I am very pleased with it, and I would stack it up against anything else that's out there front end wise at this point. It's very interesting. It's very straightforward. The main problem I had teaching people how to use Octane was to unthink all of their basically observers style mentalities from Ember Classic. But getting people up to speed on the very quirky quirks of our routing layer, which was a very good routing layer in 2012 and 2013, but it was a long time ago. Particularly around controllers, particularly around query parameters. I have scars and pain there from dealing with those, and people who have to deal with them. Like it's painful and difficult, and there is a scaling challenge there of helping people learn what is safe to do, what is not, what is a good idea, what's a bad idea. And of course, to some extent, anytime you're at the kind of scale we're at, you're going to have those kinds of things. Like if we were using React, we would spend a lot of time teaching people how to think about hooks correctly. We would spend a lot of time teaching people how to think, if you're using class-based components, which lifecycle hook should I be using here and how to make sure that I'm not overpaying for render cost and so on. But those legacy pieces of it are definitely costly. And I would finally say that the builds is a challenge for us. You can imagine at a couple million lines of code, our builds are slow. We've gotten them down. It was a running joke a few years ago that we had like hours long builds. That was before I got to LinkedIn. Now we're down at like 5.5, 6 minutes, which is pretty good for I just ran Yarn and run Ember build, but that's a lot of time. So we've been investing in switching to a mono repo where you can just run one add-on or one engine within it. We've been investing in Ember CLI. There's stuff that landed behind a flag on 328 because of research one of my colleagues did that will speed up all of your builds a lot once we kind of roll it out across the ecosystem. But those kinds of things have been, major challenges for us. When I joined LinkedIn, a fresh build like that was 20 plus minutes. That's long. You lose a lot of time. When your rebuilds are 20 seconds, 30 seconds, you just lose flow. But at that point, somebody's off on Reddit or Twitter and they've lost all their concentration. So those are some of the bigger challenges we've had, certainly.
There's 3 points I would like to add there. First, regarding the build time, measure it, because you cannot improve what you don't measure, and it creeps up on you until it's so huge that you can't possibly fix it anymore. We did the same mistake. We didn't really measure it, and all of a sudden it was like this insane amount of build time that we would have to wait. And it's a time that is multiplied by all the engineers working on the product. So it's really, really costly.
That's right.
And it's sometimes hard to make the argument for optimizing for these things. But if you really put the numbers to it and calculate the amount of money you're wasting on engineers browsing Reddit, it's actually quite a lot of money. The next thing regarding engines, I think we initially started adopting, and we have around 5 or 6 engines, I think. We initially started adopting engines because we wanted some way to slim down the initial payload size of our application that gets transmitted in the initial page load. And engines, lazy loaded engines, were kind of the only way back then. If this is what you're after, rather don't do it. Rather try to optimize for Embroider and get that working, get route-based code splitting. You're far better off with this approach. Engines are only really great if you really basically want to have separate individual applications mounted in one big application that can be developed largely independently. But there's a lot of issues and foot guns with engines. So for example, if you have some add-on or maybe even in-house add-ons that you use in multiple engines and also in the root host application, and these add-ons, for example, provide services. If you forget to explicitly inject that service as an external dependency into your engine, that engine will get its own service instance, meaning that each and every engine will have a separate service instance. And if you expect that service to be a global singleton, you suddenly have double state everywhere. And that can lead to very weird and hard to track down bugs. So that's one thing to watch out for with engine.
Yeah, I'll just add an anecdote. I was just looking up the stats on it. So in the Waypoint codebase, which is open source and not that old, it's an Ember app. It's been around for about a year. We were finding that the build was eating essentially as much memory as you could give it. So it was outgrowing the containers we were running it in on CI, and we dug around to figure out what was going on. And eventually, the one thing that had an impact was running yarn dedupe. And we went from, as an example, this isn't the whole story, but a little picture of the story. We went from having 53 discrete versions of Ember CLI Babel in the project to just 8. And that dedupe process cut the memory usage of the build by 40%. And I sort of want to use that anecdote to illustrate a truth that is not a failing on Ember's part. I think every community, every project ecosystem has a flavor of this. That is that the add-on ecosystem was a huge boon to productivity. But it comes with a really, really big maintenance cost, because every Ember app that's out there, and to everyone in the audience, I'm sure you have some flavor of this in your app, you have some package you depend on, but you get it via a Broccoli add-on or Broccoli plugin, which you get via an Ember add-on. And one of those two things isn't maintained. So you're stuck with this old version of this thing at the end of the chain. And if that has a security patch that it desperately needs, or if that thing has a bug or is leaking memory or whatever it is, you're kind of stuck unless you're willing to take over the maintenance of these two things in between. And if you don't have a Broccoli expert on the team, it's kind of like what we were talking about earlier on. But this isn't unique to Ember, not in the least. It'd be true of Webpack. I remember I used to mostly work on Ruby apps, and this was totally true of gems with particular rail ties in them and all these kind of things. Like, this is just the nature of making it very, very easy to install and integrate dependencies. It just means you're kind of pushing that connection cost off into the future. And I guess there are kind of ways to address this with peer dependencies, and things like Ember Auto Import have made this a whole lot better in recent years. But I think we're all collectively dealing with some flavor of that in build times, where it's just, really hard to get a handle on all those dependencies and where they're coming from and what's bringing them in and how. And, that is a battle that grows exponentially with the size of an application and its age.
It's not only the build time tools, it's also the dependencies that actually get bundled into your distributable. Because you can actually have add-ons that depend on other add-ons, and if they depend on different versions or the versions simply don't get deduplicated, then you may end up with a non-deterministic version in your actual compile time because only one version makes it into your bundle. And there's, for example, an add-on called Ember CLI Dependency Lint by Dan Freeman, which can lint against this. So there definitely are tools that can help with these things.
I'll do a quick second on Jamie's point about Babel in particular. Get yourself onto the whatever else you do. The biggest one you can have is getting yourself both directly and all of your transitive dependencies onto the latest versions of Ember CLI Babel. And in particular, the biggest source you will find is if anything you're using still uses Ember CLI Babel v6, fix that. That getting all of your things onto Ember CLI Babel v7 will save you an enormous amount of your build time.
I'll also say we threw away our yarn lock file and just regenerated it, and it saved I think 30 seconds the last time for a warm build. The last time we did it, we're probably due another one at this stage.
So we've heard about build time scaling. We've heard about personnel scaling. I'm really interested to hear about runtime scaling. So we're making a text editor, and it needs to be quite performant. We are kind of using Ember. We're doing some shady stuff on the side. I'm wondering if you have any anecdotes of hitting kind of the limits of updating really, really fast, doing really performant things with Ember components. Do you have any kind of scars in that regard? Situations where it just couldn't handle it?
So I'll say, number one, getting onto Glimmer components here, getting all the way into the Octane programming model is going to help. In part because you just pay for a lot less in terms of memory overhead, in terms of the cost of every single component instance being substantially lower, in terms of the cost of the actual, a getter doesn't cost almost anything. It's just a function dispatch. A classic computed property bundles all its caching with it, whether you wanted that caching or not. And so there's a lot of overhead that comes with the classic model. Switching to Octane, as an anecdote, when the messenger, the little messenger bubble on LinkedIn that pops up, we measured one of the pieces of that when we converted it. And we saw about a 20% improvement in render for that component just by converting it to a Glimmer component. We made no other optimizations. We just switched to a Glimmer component, switched to auto tracking for the small amount of internal state it had. And that we've seen consistently between 15 and 25% on anything we've measured for render performance just by making that change. I'll also say avoid duplication of state. Anytime you have to go update state in multiple places throughout your system, you're going to pay more. And then measure. One of the things that we tend to do in the front end, in my experience, is slap solutions on problems, hoping they'll help. You're really going to have to get comfortable with running CPU profiles and running memory allocation profiles and dropping them into whether it's Chrome or Firefox's dev tools. Safari has them now. They're okay and getting better, but they're still behind. There's also a great tool called SpeedScope. Go to speedscope.app. I've been using this a bunch recently to chase down a performance regression in rendering on Ember 328, which we're making good progress on. It's not a big one. It probably won't affect you the way it did us, but if you want to identify what the actual hot paths are, you're going to have to get comfortable with those. And then you can carefully introduce caching at appropriate layers. You can introduce buffering at appropriate layers and say, hey, we're only going to push this into our Ember data store after the user has typed more than one, the obvious kinds of optimizations that you want to make there. But you have to measure, because sometimes you'll have an intuition that this is the slow part, and you can measure and you're like, nah, that's fine. The actual slow part is this thing over here, which I never would have guessed. And it's also, maybe it's easy to optimize. Maybe it's hard to optimize, but without that skill and practice in measuring, you won't know. The cliffs are very, very hard to predict. They are, in my experience, as often to do with memory usage and garbage collection as they are with anything to do with CPU. The biggest predictor I see of cliffs in performance is around memory stuff. It's rarely CPU throughput of, can I render this? Though if you're rendering 50,000 components, you're going to have a problem, no matter what framework you're using. The problem is usually, though, if you're being more sensible in that space, that you're just going to hit a point where you have enough memory usage that you spend exponentially increasing time on garbage collection. And that back pressure, trying not to garbage collect, trying to garbage collect, those things will push your performance off a cliff. So measure. measure.
All right. Thank you very much. This has been tremendously educative. I learned a lot, and I hope that you did too. And let's continue in 2022. Thank you to all the panelists and all the attendees. It was amazing. Thank you.
Thanks.